Hi, everyone. Thank you for joining today's webinar. I'm your moderator, Douglas Marthaler. If you're not familiar with me, I'm the Senior Science and Technology Manager for North America. I have over 15 years of diagnostics experience and oversaw the R&D section at the University of Minnesota Veterinary Diagnostic Laboratory before jumping into industry. We have two exciting speakers today, but before we jump into the speakers, we do have a few housekeeping items to cover. One moment as I progress the screen. First, if you have questions, please ask them in the control panel. We got a few questions prior to the webinar, so we will be covering those first. My colleague Ellen Bromsted will be reading those questions during the Q&A session. If we don't get to your questions, no worries. We'll be sending out an email with a list of questions and answers as a follow-up to the webinar. Also, there's a few documents under the handout sections. Feel free to download those as you see fit. And then lastly, our agenda for today. So first, we're gonna have a brief introduction of INDICAL, then we'll cover ASF strategies, the Polish experience, then move on into innovative molecular diagnostics for the lab, a Q&A session, which will approximately be anywhere from 12 to 15 minutes, and then we'll have some few closing remarks. So moving on into our introduction, INDICAL's mission is to empower our customers to ensure accurate and reliable results. Our solutions span the complete portfolio from extraction to PCR and ELISAs. R&D collaborates with experts across the globe to develop novel innovation solutions, and R&D has over 2 decades of experience in delivering quality and reliable solutions for our customers. If you're not familiar with INDICAL, we have over 25 years of experience in animal health. We started back in 1996 as a veterinary service laboratory, and then we were acquired by QIAGEN, who's known for their high quality extractions, which we carry forward today as the INDICAL family. In 2018, INDICAL became its own company with a sole focus on animal health. And then this year, we became part of the Vimian family and joined 3 other animal health companies to strengthen our presence in animal health. One of Vimian's and INDICAL's missions is to share knowledge across the globe to better animal health. And with that, we are honored to have a speaker, Grzegorz Woźniakowski from Poland, and who's been combating ASF since 2007. Greg is a full professor at Nicolaus Copernicus University and a member of the Biological and Veterinary Sciences department. With that, Greg, thank you so much for giving up time today to present to our global audience, and the floor is yours.
Well, many thanks, Douglas, for a very nice introduction. And at the beginning, I'd like to thank you once again to Ellen and Douglas and Leslie for organizing this very important and strategic meeting. And I'd like to today share with you my experience also from my former job at the Department of Swine Diseases. And I'd like to focus on African swine fever strategy when it comes to Polish experience. Next slide, please. Thank you. So as you may know, this is not a new emerging problem because African swine fever occurred over 100 years ago in Kenya, in Africa. And well, it of course caused a huge economical loss in terms of production of domestic pigs in Spain and also Portugal in the 80s and 90s. Well, at the end, in 90s, it has been successfully eradicated. So it's also a huge achievement when it comes to effective measures of eradication in domestic pig production. But in 2007, the disease occurred again in Georgia because of transferring of pigs probably from Mozambique, from Africa. And also the contaminated pig's wheel was the potential source of introduction of the virus to the previously free area of Georgia. But after a few years, the disease occurred in all countries of Russian Federation, and also in 2014 reached Baltic states and Poland. So this is this problem could not be controlled using well, obvious ways of eradication of any infectious disease. And also this is the first case when the disease occurred in wild boar population. So this makes a huge problem in eradication application of efficient measures to cope with this burning problem. Well, the disease that cannot be controlled, as I mentioned. So also it occurred in China in 2018, and so next in different Asian countries. And in 2021, the disease reemerged in the Dominican Republic and also Haiti. So it's like a never-ending story, because the disease was not present for over 40 years in Dominican Republic. Then the disease reemerged again. So that means that it shows that African swine fever cannot be controlled using well, normal and obvious methods of eradication. Of course, it has a huge importance when it comes to production of domestic pigs in any affected countries, because if you see the purple bars showing the production in Baltic states and Poland after the 2 years of African swine fever from the introduction, you can see well, a huge decrease in number of produced pigs, and well, it's a severe threat for further production of pigs in Poland and also other affected countries, including, of course, Baltic states. Next slide, please. Yeah, so you can see many red dots in the area of Romania in Europe, and this is due to the huge problem in domestic pig population caused by emergence of African swine fever. Also, if you see the map of Poland, you can see at least 4 different clusters of the disease affected in wild boar population, and also domestic pigs. So having a look at this also bars on the right hand side, you can see that also different strategies of surveillance are implemented in different European countries. For instance, in Ukraine, you cannot see even a bar of outbreaks in wild boar. That means also the strategy of surveillance is completely different from other countries like Hungary or Poland or Germany. So this is also extremely important to know the current status when it comes to African swine fever in particular country, because without the robust and very efficient way to perform surveillance in particular country, you cannot say anything about the current status of the disease at the particular area. Next slide, please. Well, yeah, thank you. But African swine fever is not spreading disease in terms of natural spread in wild boar population. So without any additional human influence and assistance, it spreads in a range from 1.8 to over 7 miles per year. So it's not really fast spreading disease. And also some seasonalities observed, mainly when it comes to emergence of outbreaks in domestic pig sector. So the majority of outbreaks occurred from spring to summer. And when it comes to emergence of African swine fever in wild boar population, well, the new outbreaks could be detected virtually in any month of the year. And the potential causes of outbreaks in domestic pigs, of course, we have some reports from Romania that it could be the direct proximity of pig holdings. So this is also, we have also similar examples from Poland, but also the size of and the type of production. So it's well known that the production in backyard sector is especially prone to be affected by the introduction of the virus to the pig herd. And the next thing is the density of wild boar population in the particular area. That's why the effort should be focused on to keep the population of wild boar at the particular area at the level as low as is possible. Next, of course, the frequency of visits of different persons involved in some actions at the level of pig holding, and also application of green forage, hay or straw, which is sometimes used for bedding for different species of animals, including cattle or horses, could be a potential threat for pigs, because it may cause introduction of the virus from affected area affected in wild boar population. So it's also well known that human-mediated spread is one of the most important risk when it comes to further and uncontrolled spread of the disease. So it is the most important message, I think, for us. Next slide, please. And regarding the potential sources, of course, the most important source is wild boar. That's why the surveillance should be focused on testing of that wild boar at the area when we may expect new spillovers and introduction of the disease. Then, of course, different contaminated materials like contaminated feed or straw from fields where African swine fever virus is present in the wild boar. It could be the potential source of introduction of the disease to pig farm. The same with, of course, naturally contaminated farm and so on could persist for a long time contaminated. That could present an active source of the virus for susceptible pigs. Well, the next and the most potential source of introduction could be also agriculture machines like harvesters, tractors used also at the area where African swine fever is present in wild boar. And of course, European Food Safety Agency presents the report that is rather unlikely to introduce the virus with contaminated gray hay or straw, but it's more about the lack of firm evidence on that. That is, well, it's also extremely difficult to detect the virus in gray hay or straw, but it's possible to introduce the virus with contaminated crops. Next slide, please. And regarding the surveillance and also vigilance and observation of clinical signs by veterinarians supervising pig farms, but also by farmers, should be focused on signs and symptoms like lack of appetite, elevated body temperature from 41 to 42 degrees centigrade, the same abortion, and some farmers may also observe single death increase in different groups of pigs, especially in sows, in fatteners at the beginning. Then after post-mortem, the most important lesion, it's enlarged spleen, a violet spleen. The enlargement could be 10 times higher in comparison to so-called normal spleen, and the same hemorrhages in lymph nodes. These are the most important clinical signs and lesions when it comes to the observed outbreaks in domestic pigs. Thank you. Next slide. And in wild boars, where it's not so obvious to observe clinical signs or lesions in wild boar, but there are some examples from Poland. You may observe that some hemorrhages in skin, some foamy discharge, and the same with spleen. The spleen is also enlarged, and well, the color is dark violet. Next slide, please. So what are the successful methods of eradication and to combat African swine fever in affected country? First of all, application of fences, like collective fences, like multi-site fences, were successful, for instance, in Czech Republic, in Belgium, and well, in some parts of Poland. These also measures have been applied. And the next, and I think the most important measure in eradication of African swine fever and to break the episodic chain is to apply white zones with the area over 50 kilometers wide, where the density of wild boar population should be close to zero. That is the most important weapon to combat with African swine fever in wild boar population, and it's extremely difficult to combat with the disease. Besides chemicals, well, it's difficult to measure the efficacy of application of chemicals, but they are mainly based, all of them are based on butyric acid. And regarding hunting actions, well, the hunt strategy of hunting should be smart. What does it mean? That application of snipers, of mainly police snipers and well-trained snipers, which are able to to successfully depopulate the wild boar at the particular area, especially close to domestic pig holdings. And next, awareness campaigns. Well, it's crucial, as we see from experience of Poland. It's crucial to continuously organize awareness campaigns for all stakeholders, including pig producers, hunters, and veterinarians, of course. Next slide, please. When it comes to Poland, you can see on the left-hand side many bars showing outbreaks in domestic pigs. So you can see it's extremely difficult to control also African swine fever in domestic pig production, in spite of measures implemented to control the disease. And at the beginning, it was maybe we were a little bit naive, because we thought it's possible to keep the disease close to the eastern border, because there were only some outbreaks in wild boar at the beginning, but it's not possible to control the disease in wild boar population efficiently. And also, as you see, the human-mediated factor is crucial when it comes to emergence of the disease at the previously free areas of Poland. Especially, you can see the western cluster close to the German border. Next slide, please. And the main drivers I already mentioned about the potential source of introduction, and the most important, I think, is not compliance of biosecurity rules by some pig producers. So especially handling of pigs with other species, as application of straw or hay for bedding for these animals could be the potential source of introduction of the virus to pig farm. The same lack of understanding, lack of awareness when it comes to disinfection processes could be the potential threat for production of pigs, and human activity in contaminated areas. So that's why it's so important is organization of awareness campaigns for pigs producers, especially. There were also some exceptions of illegal movement of pigs or the sellers of pigs, which were infected with African swine fever. Everything is possible without human awareness at the end. And well, as I mentioned, without strict implementation of biosecurity measures, it's difficult to keep the disease away from pig sector. And parallelly, it's extremely difficult to control the disease in wild boar population by obvious methods of measures of eradication. Next slide, please. And of course, the methods recommended by EU also include application of surveillance zone, protection zone. These regulations are applied to keep the disease under control after the emergence of the single outbreak in pigs. So also the strategy of surveillance, it's crucial to control the disease at that particular area. So all dead and sick pigs should be, with clinical signs, should be tested for African swine fever to exclude the infection with the virus. All wild boar found dead, especially, should be tested for African swine fever virus. And this is the most important and the first alert of the potential introduction of the virus to previously free area. The same with hunted wild boar, but from the history and my experience in Poland, the number of the percentage of positive hunted wild boar is not higher than 1.5%. So it's not so informative like in case of dead wild boar. Next slide, please. So what is next for the affected country? Well, I believe in efficacy of application of EU eradication measures, including regionalization and all recommended ways to cope with this problem at the affected area. And well, in case of lack of further eradication measures in the future, because the majority of country could be affected by African swine fever, so I believe the only solution could be the regionalization and the implementation of strict control over the production of all pigs from pig sector, from production of pigs at the farm level, through slaughtering houses, to processing plants, and also the control over the all these steps and focusing on surveillance of particular steps of pig production. So this is the worst scenario, but at the end it could be the only effective way, the only possible way to still maintain the production of pigs within the affected country. Thank you. Next slide. Well, with that message, I'd like to thank you for your attention, and well, once again, thank you for organization of this very interesting meeting, and I hopefully take some questions from you. Thank you.
Thank you, Greg. As a reminder to the audience, we will be fielding questions during the Q&A session. So hopefully, I see that there's a few chat bars popping up, and I hope those are some really great questions coming in for the Q&A session. Next, we'll be moving on to innovation molecular diagnostics for the lab. And with that, I will introduce Ahmed Elnagar. He's currently at the LFI Institute, the Federal Research Institute for Animal Health in Germany. Ahmed is one of the authors of the swift and reliable easy lab methods for sensitive molecular detection for ASF. And he'll be sharing his experiences from a lab level and his research on point of need or pen-side applications. Thank you, Ahmed, for joining us today, and the floor is yours.
Thank you, Douglas, for the kind introduction, and for you, Ellen and Leslie, for the great organization, and it's a great honor for me for joining you here. Yeah, my name is Ahmed. I'm working at the FLI, Institution of Diagnostic Virology, and today I would like to share with you our recent ASF research work with the title of Innovative Molecular Diagnostics for the Lab and PIN. First of all, the actual epidemiological situation in Germany. September 2020, we got the first ASF outbreak in wild boar, and it has been located in the region of Berlin-Brandenburg, and it was close to the Polish border. Therefore, the probability of introducing the virus to Germany was by a migrating wild boar from Poland. Due to the geographical distance to the nearest ASF case, it was around 30 kilometers. However, it was not excluded that the virus may be introduced to Germany through the people with contaminated meat, pork meat, or pig products. Our control and eradication measures were 3 kilometers as a core zone, 15 kilometers as a risk area. Inside of this area, there was no harvest, nothing was operated. Outside of this area, there were around 700 hunters for an intensive searching of wild boar carcasses. And samples were taken and tested daily at the state laboratory. Every fallen wild boar that found it, that should be immediately reported to the responsible authorities. Afterwards, in July 2021, next slide please, yeah. We got the first ASF case, but on domestic pigs in 2 different regions, as you see here on the map with the red dots. First, it was an organic farm in the district of Spree-Neiße, and that was located in an infected core zone, which was established by the first outbreak in wild boar. Secondly, it was a small holding with 2 pigs in the district of Merich-Oderland, and this area was located as or defined as an ASF-free wide zone. The cause was exactly unclear, but we were expecting that ASF will catch domestic pigs because of the virus transmission between wild boar and domestic pigs. Control and eradication measures were conducted, and until now, we have 3 outbreaks in domestic pigs with a total number of ASF cases in Germany around 2,506. That was the last week and is still increasing. And that was the first way of fighting against the virus from the epidemiological side. On the other hand, we were working on ASF research for development of rapid detection methods as a tool of disease control. Next slide, please. The aim of our study was to develop, establish, validate an innovative molecular diagnostic platform for the speed and system detection of ASF. Our main work plan was EasyLab, which is focusing on sample lysis and nucleic acid extraction using different preparation systems, real-time PCR assays, thermocyclers, and kits for the genome amplification. And now, what is the definition of EasyLab, or how could we implement the EasyLab concept for ASF? It was about the simplification and standardization of the molecular diagnostic workflow in the lab. And here we were aiming high sensitivity and specificity combined with robustness, and the use of easy to handle machines and software that will reduce the training efforts and misinterpretation of the results. And that should be applicable for the persons and labs with limited resources and experiences in the molecular diagnostics. Next, please. Moving up to diagnostic methods, our workflow based on three main comparison studies. Firstly, a comparison of different sample matrices based on different animal trials to can identify what is the best sample material for ASF diagnosis. And here we conducted animal trials under the biosafety level 4 of condition at the FLI. Could you please, Douglas, the next slide? Yes, thank you. And we enucleated the animals with different virus strains like the Estonia 2014 and 2 different strains from South Africa. And here we have some pictures. How did the animals look like after the infection? And we sampling the animals every day, and we collected mainly ADTA blood samples, serum swabs, and chewing groups at different time point post-infection. Next slide, please. Secondly, it's comparing and evaluation of different extraction methods. And here we used the standard manual hand extraction viral RNA mini kit from QIAGEN compared to the nucleomagvit kit, which was conducted in the Kingfisher system. Furthermore, we used the INDIMAG pathogen kit that was performed, as you see here, on the INDIMAG 48 extraction instrument. From this kit, there was a variant which was called pre-fill cartridge. And here you have 2 options. Up to 48 samples, you can use on the right side, the IM48 that can be conducted on the INDIMAG 48 instrument. If you have samples up to 96, you can use the left one that can be conducted on the Kingfisher system. Furthermore, we tried to release the ASF nucleic acid without any extraction kit. And here we used the virotype tissue lysis reagent from INDICAL, and that was originally developed for the fast preparation of various sample types without the need of any extraction kit or any complicated isolation procedures. And it has been successfully performed for the diagnosis of bovine viral diarrhea virus and has been published in 2019. Next slide, please. And thirdly, comparison of different real-time PCR assays and kits and thermocycler. Here we used mainly our in-house standard Highness assay combined with the Perfecta qPCR tough mix compared to the OIE recommended method from the European Reference Laboratory Tagman assay, which was called previously as UPL probe. And we combined that with the LightCycler master kit from Roche. Furthermore, we used the virotype ASFV 2.0 from INDICAL, and this kit is offering a triplex real-time PCR with its double control strategy as an amplification control and extraction control. And the first 3 assays, we conducted that on the BioRad CFX96 thermocycler. The last variant we used, it was the INDIFILD ASF PCR assay, and they are ready to use lyophilized reagents that can be performed in individual tubes, as you can see on the slide, that can be applied on the INDIFILD thermocycler. And this is a battery holding PCR machine, which is fully controlled by a smartphone. You can easily perform your PCR run just by the Bluetooth connection and scanning QR code. You can find that on the package of the kit. and you get the results. Very easy to analyze, and for more details about the PCR run, you can upload the whole PCR data on a cloud system. Next slide, please. Moving up to the results concerning comparison of sample matrices. From the first animal trial, we collected ADTA blood and serum from 5 animals which were inoculated with ASF Estonia virus strain, and we collected the samples on the day 4, 7, and 10. And here the black bars are referring to blood samples, gray one referring to the serum samples. As you can see, virus could be detected at all time points in both samples, serum and blood, but with a significant difference of the values between serum and blood. Next slide, please. From the second and third animal trial, we tried to test a wide spectrum of samples to be more accurate about the best or choosing the best sample material for ASF diagnosis. And here we added oral swabs and chewing ropes that was collected from 4 animals which were inoculated with the 2 different virus strains from South Africa. And here we collected the samples on the day 3, 4, 7. As you could see from the first animal trial, in the blood and serum samples, virus could be detected at all time points. In tendency, serum could deliver more or less similar values compared to the ADTA blood, but just in the late stage of infection. On the other hand, oral swabs and chewing groups, the virus could be detected just in the late stage of infection, with a high significant difference compared to the ADTA blood and serum samples. What we can conclude here that ADTA blood is the most suitable choice for ASF genome detection in both phases of inoculation or infection. Serum sample is working fine, and that could be comparable to ADTA blood, but just in the late stage of infection. Oral swabs or chewing groups, what we can call the non-invasive samples, could detect the ASF just in the late stage, probably based on the ascending viremia, but in general, we found out that these sample materials are not convenient for the ASF diagnosis. Next slide, please. Regarding the comparison of extraction methods, based on 30 animals, the same samples materials were collected. We compared our extraction methods with the corresponding sample volumes from each manufacturer. As you can see here, all tested extraction methods more or less are similar and comparable to each other, and they were efficient and sensitive for nucleic acid isolation. What was here interesting was the tissue lysis virotype reagent, which could deliver similar results to the standard automated extraction systems. And here we could find, or we could deliver the message that TLR could be an alternative or good option for the ASF molecular diagnostics, especially in the cases of lack of any commercial extraction kits. And we had the real situation of that with COVID-19 that has generated a huge consumption of extraction kits. Therefore, we found out that TLR could be a good alternative option for ASF molecular diagnostics for the release of ASF nucleic acid without any extraction kits. Next slide, please. Here, regarding the PCR assays and commercial kits from the same animals, the same samples, we compared the 4 assays of PCR, and as you can see, virus could be detected by all assays and demonstrated analogous efficiency and correlation with the both thermocyclers. And here, what you can see that INDICAL assay demonstrated the highest sensitivity and the highest CT values, probably based on the high template volume, based on the amount of the lyophilized reagent. But in general, all assays, all kits, the virus could be detected in a comparable and sensitive way. Next slide, please. Here, for more accuracy and reliability of our methods, we tried to test our diagnostic methods with the field samples that we received from the first outbreak in wild boar. And here we picked up 16 different samples which were consisting of bloody swab suspension, serum, and bone marrow samples. The DNA was extracted by the standard automated extraction systems, the INDIMAC pathogen kit on the INDIMAC 48 instrument, compared to the Nucleomag Vet kit that was conducted on the Kingfisher system. For the PCR amplification, we compared our 4 assays, and here the graph is showing the mean CT values based on the 16 different samples. As you can see, in the both extraction systems, ASF virus could be detected by all 4 assays. More or less, they delivered similar results. However, you can see the virotype assay could deliver more sensitivity than our standard assay, Highness assay, and the OIE recommended method. And as I mentioned, that the INDICAL assay could demonstrate the high sensitivity due to the high template volume. Next, please. What we can summarize in our study that concerning the sample matrix, EDTA blood and bloody materials are the sample matrices of choice, independent of the course of infection. And if these samples will be used, you have different several extraction and qPCR methods are fit for the purpose. The selection of ideal system in the lab depending on various factors, such as how many samples you have to do every day, technical personal resources in the lab, necessity to use certified kits. Therefore, we try to develop or to promote a wide range of diagnostic methods that could be fit and possible for the different labs. And in our study, we could show that the simplification and standardization of DNA extraction qPCR methods does not result in the reduced diagnostic sensitivity and reduce the risk of false negative results, especially in the high throughput scenarios. And our study has been published recently, and you can come back to this as a reference if any more details are required concerning the methods or the results. Next slide, please. What would be our next ASF research at the FLI? That would be the application of molecular pin site test for the ASF genome detection. And it's about the realization of the molecular diagnostic methods in the field. It's called pin stable herd near to the patient. And here we are aiming appropriate sensitivity combined with high specificity. And the results should be applicable and also understandable for the less trained persons in the field, with a time frame from 30 to 60 minutes. And here we will conduct some different comparison studies between extraction systems like the INDIFIL sample prep cartridge and the nucleic acid release by the tissue lysis reagent and EEE system. We will do comparison of different qPCR cycler such the MyGo Mini, Liberty 16, and the INDIFIL thermocycler. Furthermore, a comparison of different qPCR kits, if it was liquid or lyophilized, commercial or in-house, that will be our next development and validation of ASF in the field. Next slide, please. And here I'm coming to the end of my presentation, and I would like to thank my colleagues, Professor Dr. Martin Beer, Dr. Sandra Blume, my supervisor, Dr. Bernd Hoffmann, Dr. Jutta Pekalo, and for the technical assistants, Karen Christian. A great thanks for INDICAL Bioscience for their support of my work. Thank you for your attention.
As a reminder, INDICAL had a few innovative solutions that were mentioned in Ahmed's talk. First, we have the INDIMAG 48S that increases flexibility and saves plastics associated with extraction. And he also mentioned pre-filled cartridges that saves time and increases workflow efficiency within the lab. Something new that we did not talk about is a novel approach for diagnostic testing, which is air collect. So this is where we will sample the air for the detection of pathogens that will be circulating within a farm. My hope for air collect is this will be a replacement for oral fluids, as I know lots of labs do not like working with oral fluids, nor do I like working with oral fluids in the lab. So more to come on that technology. Everyone, please sign up for our next educational webinar. You can scan this QR code to get registered. Some future topics will include air collect, sampling through the air, staying ahead of PERS, BVD, sharing different experiences, and etc. Also, you will receive 2 emails from INDICAL. The first email emails as a follow-up from the webinar. The first email will include a recording of today's webinar, questions and answers, so the questions we were able to get to and then the questions that we were not able to get to, and then how to reach out to your local representative for additional information on anything that you heard today, and we can also put you in contact with the presenters as well. The second email will be a survey of feedback on today's educational webinar. Please complete that. That helps us make better webinars in the future, and that just helps us increase the sharing of knowledge to the global community. Lastly, I would like to thank our speakers one more time, Greg and Ahmed. Without their help and their support, we would not be able to make this webinar available for the community. And with that, I would like to thank you for attending. Please reach out if you have any questions and stay in touch, and hopefully we'll see you at our next educational webinar. Take care, everyone, and have a great day.
Take care. Thank you.